Okay, finding distances when you have a bearing and you have one known distance. Exercise 2C has a lot of questions like this. Nearly every question actually has a drawing, but if you're given a worded question, your first step is to draw it. Step 2, make a right-angled triangle that includes the side that you want to find. Now, you won't already have a right-angled triangle. You'll need to drop a line down or drop a line across to make one. Step 3, work out an acute angle. Now, there'll be two acute angles, won't there? If there's a right angle, then the other two angles are acute. You need just one of them, and you'll always be able to find one of them using your bearing. Step 4, follow the usual method using trigonometry to find an unknown side. So you've already done that and reviewed that already. So let's do an example. We've got a ship sailing 50 kilometres from X to Y on a bearing of 160 degrees true. How far south has it sailed? All right, from X, it's leaving from X. So X is the first thing I draw. I give it a north sign, straight up, and I send it off on its bearing of 160 degrees, thinking to myself, 90 is here, 180 is there, so 160 is going to be round about here. Get my drawing looking about right. So here's Y. Now, it sails 50 kilometres, so I know that that distance is 50 kilometres, and I can write that in. All right, now the question, this is where you can get confused. The question says, how far south has it sailed? And people sometimes look at that and go, oh, well, it's gone 50 kilometres. But how far south means how much further south is point Y than point X. And that means we need to extend this line down, heading south, this is a straight line, until we get to a spot where we can go straight across and build our right angled triangle. So this is due south here, south. So what we really want to find is this distance. Let's call it X. Okay, now we've got an unknown. Now we're going to need an angle. We either need this angle or we need this angle. And you can find either one. We can actually find either of them using this bearing. So it's up to you, whichever one comes easily. If this is 160 degrees, because that was our bearing, this one looks like the easiest one to find, doesn't it? And it would be 20 degrees. But just as equally easy, if we saw that this was moving up this way, this would be 20, and this in here would be 70. You can figure it out. There's always more than one way to do these questions. So if you've got a different angle that you're using on a question than the person beside you, as long as your answer's right and your working makes sense, that's fine. All right, now we've got a triangle. We've got the hypotenuse, which is 50 kilometres. It might be tidier if I write that over here now, so it's out of the way. And we've got X here. So based on our angle of 20 degrees, we've got the adjacent side and we've got the hypotenuse. Now thinking through your SOHCAHTOA, adjacent and hypotenuse tells us that we need to use cos. So we write out our equation, cos of 20 degrees equals adjacent, which is X, over hypotenuse, which is 50. Now we need to rearrange it so that X is all by itself. At the moment it's X divided by 50, so to fix that up we can multiply both sides by 50. So multiplying this side by 50 will just disappear the divide by 50, but this side will be 50 times cos 20, won't it? Now I'm going to write the X down first because I like that, having that on the left hand side, and this one will be 50 times cos 20 degrees. Now at that point I need to reach for my calculator and I just type in 50 times cos 20 and I've got 46.98. Now let's say it was said to the nearest kilometre, then I would say X equals 47 kilometres to the nearest kilometre. Now, if you're rounding off, always put in brackets what you've rounded it off to. Now, how could they trick you here? How could these questions vary? Well, let's imagine that we were asked the exact same question, except instead of saying how far south did the ship sail, they might have asked us how far east did it sail. Now, it's gone from here to here, so it's sort of gone southeast, hasn't it? This is the southerly direction and this is the easterly direction. So if that was the case, we would have put our unknown on this side and we'd follow a similar arrangement in here, except we would have had opposite, so we would have used sine.